Hi everyone, welcome today to the Corda Coding Bootcamp. We'll just wait a couple of more minutes before we get started. It's great to have you all here today. I'm just gonna wait for a couple more minutes and we'll get started. Okay, so hi everyone, I'm Janine, a developer evangelist here at R3. And I think we're good to get started, and whoever joins a little later on can then just catch up. So 2 weeks ago on the 1st of September, we held a Corda 101 session where we explored a high-level introduction to Corda, the different networks in Corda, as well as CorDapps and its components. And so for today, at the very beginning, we'll do a quick revisit to the intro to CorDapp part, as well as the CorDapp components, just for those who might have missed the Corda 101 session 2 weeks ago. And of course, the majority of today will be focused on the live coding session. I'll be asking questions throughout the presentation, so make sure that you're paying attention, and if you have any concerns or questions throughout the presentation, then please just leave them in the chat box, and my colleague Peter and I will go through them when we do our midpoint check-in, as well as at the very end. So let's start with a quick intro to CorDapp. So CorDapp stands for Corda Distributed Application. And a distributed application is a compute application that also runs on the distributed computing system. It's also sometimes referred to as smart contracts in other blockchain communities. And CorDapps are simple binary jar files that are stored inside the Corda nodes. Each node can carry one or multiple CorDapps. So for example, you can have a supply chain app and an insurance app running on the same node simultaneously. So let's take a deeper look into CorDapp components. Here are the three key components to CorDapp. So first we have state, and a state is an immutable object representing a fact known by one or more Corda nodes at a specific point in time, and they represent facts on the ledger. A state can be consumed as an input state of a transaction, it can be created as an output state of a transaction, or it can be stored on the ledger and is therefore immutable. So the next key component is contract, and contracts verify transactions. So in order for a transaction to be verified, it has to pass all of the rules set in the contract. And last key component is a flow, and flows execute business logic. So all the calculations, verifications, signings, and data writing gets executed in the flow. So let's break this down a little bit more and take a look at a simple example to see how these key components work together. So in this diagram, we have two states. We have the input state at the top as well as the output state at the bottom. And in order to get from one state to another, we need to build a transaction. So as you can see, a transaction consumes the input and output states, but we need to run this transaction through the contract rules to ensure that the transaction abides to the rules that we've set. So for example, in a case where we would like to sell a car, an example of a contract rule could be that the car cannot be sold for less than 80,000 USD. And if the proposed ledger update is to sell that car for 70,000 USD, then the contract rule will fail as a minimum of 80,000 USD has not been met. This means that the transaction can't update the initial input state in the ledger with the proposed output state because the verification process has failed. And so the ledger update request has been rejected. So let's see a passing example. So back to our car. If the minimum selling price is set to be 80,000 USD, as we had in the same example previously, and the proposed ledger update is to sell that car for 80,000 USD, then it's all good. And the contract rule will therefore pass as a minimum of 80,000 USD has been met. This means that the transaction can update the initial input state in the ledger with the proposed output state because the verification process has passed and the ledger update request has been therefore accepted. So moving on, let's take a look at the flows in more depth. So as I mentioned just now, flows execute the business logic, and flows actually consists of two classes. We have the initiator and the responder. And in this diagram that we're looking at, it depicts a simple flow in the CorDapp. So node A is trying to propose an update on a single state. And in our case, because node A is trying to propose an update, it will act as the initiator and node B will act as the responder. So let's go step by step through this diagram. So first, node A proposes a ledger update, and then it checks that the proposed ledger update is correct, and then they sign this transaction. Node A then sends this proposed ledger update to node B, which is partially signed. And then node B checks the ledger update, and if they're happy with it, they will also sign the transaction as well. So once all related parties in this transaction, in this case, node A and node B, have signed the transaction, they will then send the proposed ledger update to the notary pool. And the notary pool will run a uniqueness consensus service. So it'll either sign the transaction in cases where all the input states are found to be unique, or the notary pool can reject the transaction and flag that a double spend attempt has occurred in cases where that specific input state has already been used in a previous transaction. So let's say in this flow, the notary pool has verified that there is no double spending and signed the transaction. The ledger will then be updated, and node A and B, the initiator and responder, will both record the ledger update. Okay, so just before we get moving on to live coding, I just want to ask you a couple questions to make sure that you've understood everything okay and that we're on the same page. So first question is, a node can have multiple CorDapps running at the same time. Do you think that this is true or false? Try to put in the chat what your answer is. Is it A or is it B? What do you think? I believe you can try and comment now. Yeah. Cool. So a few people say A. Some people say B. What do we think? I'll give you a couple more seconds. Can a node have multiple CorDapps running at the same time? Okay. And the answer is A, it is true. So let's go back to the slide where we were talking about binary jar files. So as we mentioned here, each of these nodes can either run one or multiple CorDapps at the same time. So well done to those of you who said A, and if you said B, no worries at all. Now you know that that's the reasoning behind it. So the right answer is A, true. So the next question, what does a state in Corda represent? Is it A, state of all customer accounts? Is it B, a global state of the ledger? Or is it C, a fact known by one or more parties? I'll give you a couple seconds again. A lot of people saying that it's C, some people saying it's B. Any more answers? Okay, and the answer is C. It is actually a fact known by one or more parties. As we mentioned before, a state is an immutable object representing a fact in the ledger known by one or more Corda nodes at the same time. So that is why it is C. So the third question, what does a contract in Corda represent? Is it A, where each node can create a transaction? Or is it B, optional documents attached to a transaction for legal purposes? Is it C, where there are no contracts in Corda? Or is it D, the set of constraints that govern the evolution of state objects. A lot of people are saying D. All right, and the answer, I'll give it a couple more seconds. Still people answering. The answer is D. I think everyone got it correct. Well done, everybody. So this is where we set the rules, and only if all the rules are valid do we then allow for the transaction to take place, as we saw in the example with the car not passing, with the ledger update, and also with the passing of the ledger update. Okay, so I think we're all good here, and I'm happy to move on. So now that we've gone through all of that, it's time to get our hands onto some coding. And throughout the session, you'll be able to find additional documentation at docs.r3.com if you want to find out more. I'm just going to show you the website here. This is where you'll find all the technical documentation that we have on Corda, as well as other like Conclave. So feel free to take a look after the session if you want to read more into anything in particular. And yeah, so let's get started. Before we do, though, we do have a couple of prerequisites. So you can do this afterwards if you haven't already had these things, but we'll need to install Java 8 JDK. We also need IntelliJ and IDEA. We need Git, and Gradle is optional. So today we'll actually be building a simple CorDapp. And I just want to let you know that all of the instructions for this coding session is in the Bootcamp-CorDapp repo on the Corda GitHub. So it is in this link, github.com/Corda/bootcamp-CorDapp. And I will just show you what it looks like. So this is it. And sorry, I'm just looking at the Q&A. Okay, so this is it. This is the CorDapp repo. And yes, I will add the link to the chat so you can have a look. So I've just added it there. And if you wish to, you can find this repo and clone it during the session or after the session as you wish. And for today, we'll actually not need to install Gradle, as the included Gradle W script should install Gradle automatically when we open the sample CorDapp in IntelliJ. So I'm just going to show you, just in case you're not familiar yet. In order to clone the repo, you just have to go to this repo link, as I shared in the chat, and then click on code here and just copy this HTTPS link. And then you can open any terminal. You can do command prompt, or in my case, I'm using iTerm. So let me just increase the size here for you. And you just do git clone and you paste the link and press enter in whatever folder you want it to be cloned in. And that's basically it. So as I already have it cloned, I don't really have to do this. So I'm just gonna skip this step.
Jenny,
yeah.
Make sure you zoom in the font, make the font bigger for the terminal.
Okay, is the terminal, is it big enough here? Or do you want it bigger?
Okay, yeah, right now it's better. Yeah.
Okay, cool. Yeah, if anyone has any issues with like font sizes and stuff, then just put it in the chat and I'll try to accommodate as much as possible. Okay, so bigger, please, says Martin. All right, Martin, I got you. Hopefully this is okay. All right, so we don't need to use the terminal right now. So I'm just going to minimize this. And so now that we've cloned this repo, let's go into IntelliJ, and I have it opened in IntelliJ. And I'm also going to increase this. I'm not sure if I can increase the side panel, but I've already increased the font here, so you should be able to see the coding part. So
for IntelliJ you can't. So just the font is fine. Just okay. Make the font bigger.
All right, gotcha. Thanks, Peter. All right, so before we start, we want to go into workflow. So we'll find the workflow folder here, workflows, and we want to go into source, integration test, and run the driver-based test. So I'll right-click here and run the driver-based test. And this is always great to use as a dev environment check, because if we can successfully run these tests, it means that our local machine is ready to do some Corda development. So I'm just going to let this run. And let me know in the chat while we're waiting, are you coding along with us today, or are you planning to just watch this and then do it on your own afterwards? Okay, so the tests have finished running and everything looks good. Okay, so Dawn is coding along and Mike is just watching, no problem at all. I hope you find this useful. And all right, so let's go back to our presentation now that the tests look fine. And let's go through our goals for today. So the CorDapp that we're building today will allow the issuance of tokens onto the ledger. So there are 4 main steps that we have to do. Number 1 is create a token state. Number 2 is create a token contract. Number 3 is create the token issue flows. And throughout the first 3 steps, we want to ensure that all of the tests pass. So as this is kind of a template project for us to get familiar with Corda and CorDapps, there are already tests that are written for us, so lucky us, and it makes our lives a lot easier. And the last step is to build and then run the nodes in order to check that everything works accordingly. So we'll go into more depth for each of these steps, starting with token state. So for this first step, as I mentioned, we'll need to create token state, and states define shared facts on the ledger. So our token state will define a token. And token state implements the contract state interface from the Corda API, and it should include an issuer, which is the entity that issues a token, an owner, which is the entity that holds or owns the token, as well as an amount. And let's say for now that the type of this amount will be an integer, just to keep things simple. So we'll need these 3 properties, as you can see in this diagram here. So let's get to coding and let's see how we go along. So where we'll find where to create the token state, it'll be, so let's close all the folders here. It'll be under contracts, in source, in main, in states, and then token state. So you have token state here on the left. Okay, Mike, you think I'm moving a little bit too fast. All right, I'll slow down a little bit just to make sure you can follow along. So again, I'm just going to repeat so you know where to find it. It is under contracts, source, main, and then the states folder. And then that's where we'll find the token state file. And I'll have this open on the left side, and on the right side, I'll open up our state tests so that we can kind of work alongside it and see if we're on the right track. So let me know if the font size is okay for everybody. If it's too small for you, then just put in the chat and I will zoom in a bit more. All right. Too small. Okay. I will increase. Is this better? Okay, great, better. All right, so as you mentioned in our diagram here, so token state needs issuer, owner, as well as amount attributes, right? So let's create these 3 attributes: issuer, owner, and amount. And the issuer and owner are represented as nodes on Corda. So in order to do that, we'll need to use the party class from the Corda API. So let's do private final party, and we can import this from net.corda.core.identity. Issuer. So that's the first attribute. And then the second one is the owner. And the third one is an amount, which in our case, the type is an integer. And you can see that there are 3 lines that are underlined in red. And the reason why for that is because we just need to add constructor terms. So I'll select them all and press OK. There we go. Done for us. And the red underlines are gone. Okay, sorry, I'm just looking at the comments at the same time to make sure I haven't missed anything. Okay, so let's take a look at the party class and see what it actually does. If we go into the party class, So the party class has two attributes. We have name, which is Corda X500 name, as well as the public key, which will be required when signing transactions. So let's go back to our token state. So now that we've added a constructor for these three attributes, we want to define our getters as well. And in our case, we actually don't need setters because states in itself are immutable. So we just need our getters. So create getter for owner as well, and for amount. All right, so we have get issuer, get owner, and get amount. And then, because for all states in Corda, we have to implement the contract state interface from the Corda API. So let's do implements contract state interface. And as you can see here, it is also imported from the Corda API. So we just have to press enter. And then we have a red underline. So what is happening here? So basically, this error is telling us that we need to implement the overriding method of get participants. So let's do that, implement methods. And we want to do OK. And it's down here at the bottom. And this method, what it does is it simply defines who can access this information and see this state. So in our case, we don't want any random stranger to come along and take a sneak peek into what is in the state. We only actually want the issuer and the owner to be able to see this information. So what do we have to do? We just have to add arrays and import this dot as list. And we want to add the issuer as well as the owner. So that is basically it for our token state. And how do we check to see if we've got everything done? So what we can do is take a look at the test folder or the test file, sorry, for states. And as you can see here, at the beginning of our test file, to answer your question, Mike, as I mentioned just now, get participants is a method that defines who can access this information and see this state. And to answer your question, Subra, this is in Java, the language. Okay, so moving on. So now that we've written that, we just want to make sure that our tests pass. And on line 13 and 14 of the test file, we have two mock test identities. And the reason why we need to do that is just so it helps with testing. The test identity is a class which is also taken from the Corda API. So this is great for testing. And let's go through the tests and see what exactly they're testing for. So I'm going to pull this out a bit so we can read the sentence. So the first test here says token state has issuer, owner, and amount params of correct type in constructor. So let's uncomment that and give it a run. And it seems like it is correct. And in fact, actually, I might not go through every single test and run it individually because it would take a long time. So I'll go through each of these tests now and then run it all together. So the second test here, token state has getters for issuer, owner, and amount. And yes, we already created the getters for issuer, owner, and amount. The third test here, token state implements contract state, which is also done because we did that at the very top here. Token state implements contract state. And the last test, token state has two participants, the issuer and the owner. And that is already done as well. We have get participants, issuer, and owner. So let's uncomment these tests and run them all. So I'll run state tests and give it a moment. And all seems good. So now that the token state is done, we can move on onto our contracts, token contract. So let's go back to the presentation. So this token state is check, done. Next, we have token contract. So as we mentioned previously in Corda, contracts are used to verify transactions. And our contract, token contract, will define how our token states evolve. So the token states that we just built just now, this contract will define how it changes. So as we mentioned before, in order for a transaction to be verified, it must pass all rules set in the contract. So looking at this diagram for issuance transaction, first, we start off with no input states, and then we call the issue command, and alongside this is the issuer, who is a required signer. And then as an output, we want one token state to be issued, and this token state should include the issuer, owner, and a positive amount as the attributes. And Mike, this test file is already in the repo, so you don't have to do anything to write the test file. These tests are already written in advance to make our lives easier, as I mentioned earlier. So all good. So let's go to the next slide here, where we go through all the rules that we want to include in our token contract. So first rule is that the transaction should have no input states. Second rule, the transaction should have one output state. Third rule, the transaction should have one command. Fourth rule, the output state must be a token state. The fifth rule, the output token state amount should be greater than 0, so that it's a positive amount. The sixth, the command is an issue command. And lastly, the command lists that the token state's issuer must be a required signer. So now that we know that we want to write these 7 rules, let's go back into our code. And we want to move from token state folder, or the token state file, sorry, into the contracts file. So contracts file is just above the states folder up here, and we want to open token contract. Okay, and on the right-hand side, same thing, we want to open contract tests now that we're working on contracts. So I will close the right panel a little bit, or minimize the right panel a little bit, so we can see what's happening here in the token contract. So for all contracts in Corda, just like the state, we want to implement the contract class from the Corda API. So let's do that. Implements contract state. And as you can see, as you start typing, these suggestions already come up. So it makes our lives a lot easier. So we just want to implement contract class. There we go. That's done. And as we said, this token contract takes care of how the token state evolves, right? So how does the code know that we want to connect this contract with the state that we built? So we need to actually go into token state and put in this line, belongs to contract, token contract.class. So if we uncomment that and we import it, we import this class and we also import belongs to contract, this will let the token state know that this token contract governs how this token state evolves. If we don't put this line in, it won't know. So we have to put it in just to make sure that they're connected. So back to our token contract. So now that we've linked the token contract with the token state, we can start to kind of look in this file and see what is happening. So on line 16 here, we define the contract ID as in a production CorDapp. As the app scales out, we might have multiple different states and contracts. So by identifying the contract using a unique ID string, it'll be easier to know which contract we're referring to. So there it is, our ID string. So down in the middle here on line 19, in all contracts, we need to use the verify method to define all the rules that the transaction must abide by. So as you can see here, we have the verify method, and it takes the transaction as a parameter. And here we want to put all our rules, all our checks to see the rules that we want to set for the token state. And then at the very bottom here, starting from line 24, we have the commands interface, and the commands interface extends the command data class from the Corda API. The command interface, defines the different types of commands that can take place with the state. So for instance, in this case, we have issue because we want to issue a token. but in the future, we might also have transfer command or settle command, etc. So, but to keep things simple, in this example, we'll just have an issue command. So now that we've kind of looked through what is in the contracts file, we can start to take a look at our tests and see what rules we want to set. So first test here, token contract implements a contract. So we already did that. Is up here, token contract implements contract. The second test is token contract requires 0 inputs in the transaction. So as we saw here, no input states. So we want to make sure that we don't have any input states for our transaction. So let's get writing. We need to write this rule inside the verify method so that it knows to check for this. So if, let's say, we want to go into the transaction and get the input states and check the size, and this should not equal to 0. And if it doesn't equal to 0, this is when we will throw an error. So it's kind of a bit confusing, but basically we want to write a scenario where it is the opposite of our test. So because we're trying to throw an error. So if it doesn't equal to 0, that is when we will throw an error. So we want to do throw new illegal argument exception. And we can say token contract requires 0 inputs in the transaction. It's quite hard to be zoomed in so much and show both sides, but basically what this does is it checks that if the transaction's input state's size is not 0, then it will throw this error, which is exactly what we want. I hope that makes sense. And then you might be thinking, okay, so looking at this test, why are there 2 different checks, right? So to help you answer that, the first check here checks that if an input is existing, if there is an input, then this test should fail, right? So here you can see on line 33, we're giving it an input. And because we're giving it an input, it should fail. Whereas in the second test here, second part of the test, it checks that if it has no output, it will verify. So here the difference is we don't have an input in the second transaction. In this case, because there is no input, then it verifies. So let me just uncomment these 2 and run contract test to make sure that it is right. And I think maybe in this case, again, I should probably just go through all of the tests and then at the end uncomment the tests to run them all. But so far, it seems like we're on the right track. Test results are good. So it's a bit reassuring. Okay, next test. Token contract requires 1 output in the transaction. So let's go with that. So we want to see that the output size of the transaction, the output size of the transaction should equal to 1. So if it doesn't equal to 1, that's when we want to throw an illegal argument exception. So if transaction.get outputs dot size, if it doesn't equal to 1, that's when we want to throw an error. And we can say token contract requires 1 output in the transaction. All right, moving on to the next test here. So scrolling down, token contract requires 1 command in the transaction, which is exactly what we want, right? We only want to have 1 command to issue the token. So we want to go into transactions and get commands. Oh, sorry, get commands and check that the size of this get commands is, if it's not equal to 1, then we'll throw another exception. I think I can remove bracket. Okay, so if it's not equal to 1, so if the command is more than 1 or less than 1, we want to throw an error. Token contract requires one command in the transaction. And then moving on to the next test. Token contract requires the transaction output to be a token state, which is what we discussed earlier, right? We want to have an output of token state, which has an issuer, owner, and amount. So let's do if transaction.get outputs. And we want to get the instance of token state there. And this is the negative of it, right? So if it doesn't match up, sorry, this should be output, then we want to throw an error. So if it's not a token instance of a token state, then we want to throw an error. And we can say token contract requires the transaction output to be a token state. All right, so this seems good. And then the next test is token contract requires the transaction output to have a positive amount. So the reason why get output is takes in 0 is because we want to take the first element in the array. So that is why we put 0. Otherwise, it just takes the whole thing, which isn't what we want to compare with. I hope that makes sense, because there could be several outputs, not just one. Okay, so moving on. So yeah, we just said that token contract requires a transaction output to have a positive amount. So we want to get the transaction output. So first we can do token states, and we want to create get the outputs of it, of this transaction. And then we want to say, for if it doesn't, if the token state amount is not greater than 0, then we'll throw an error. So token state get amount, and if this number is not greater than 0, then we'll throw new error. Token contract requires the transaction output to have a positive amount. All good. And then moving on, I believe we're very close to the end here of our tests for token contract. So token contract requires that the transaction command to be an issue command. So we want to make sure that we are doing issue command. So if it is not, so if the transaction command value is not an instance of token contract commands issue, which is the command that we created, then we want to throw an error. Requires the transaction command to be an issue command. Okay, let's just take a look at this. This one that we just wrote. So if the transaction command value is not an instance of the token contract commands issue, which we just created in token contract. Here, if it's not this, then we want to throw an error. So hopefully that makes sense. And then I think this is our last test for token contracts, which is great news. So token contract requires the issuer to be a required signer in the transaction. So we want to say, we want to see if the transaction get commands dot get signers contains, we want to say token state, get issuer, get owning key. And if it isn't equal to that, so we will then throw another error. So let me just walk through that last test we wrote. Yeah, I'm going to go through that. So transaction dot get command get signers. So we want to get the signers of the command. If it contains token state dot get issuer dot get owning key. So going back to token state, remember we had get issuer, and the issuer is a party where we can have the name as well as the owning key, right? The public key that is required to sign. So we're just checking for this public key, is this contained in get signers? Is this required in order to sign it? And if it isn't, then we want to raise an error. So I hope that this makes sense. And Sue, yes, the video recording of the session will be shared afterwards. So hopefully that helps. So I think that's all the tests that we need to write. So I'm going to go through that and uncomment it. Oops. Just go to the bottom here and uncomment. And then we can run the tests for contract tests. So let's give it a second. Seems like it's all good. Awesome stuff. So just a recap, in token contract, we wrote the rules that help govern how the token state will evolve under the verify method. So here are the different rules that we wrote. And if these rules don't pass, it will throw an error. And then you will be able to see what exactly is the problem. Hope that makes sense. So going back to our presentation, Arbinda, sorry, at the moment, we don't have a similar library for Golang. At the moment, it is for Java and Kotlin only. And CorDapp solution file has different logic in the contract class. The reason for that is because there are several ways to do it. So it's up to you, whatever way you'd like to do it. As long as the test passed, then you're good to go. And to answer your question, Mike, are these rules always the same for all apps? The answer is no. So it's up to you as the developer to decide what the rules are, right? Because for each state, it can be for different things. For example, in our car situation, if we're writing a car state, the rules will be different in that case. You know, for example, the price of the car could be a certain amount. So it's up to you to find these rules. They're not always going to be the same, but because we're issuing a token in our situation, then we can define what rules we want to set for the issuance of the tokens. And Gaurav, to answer your question, yes, we can share this code also after this session has finished. So I hope that helps. So going back to your presentation, so we've done token state, and now we've just finished token contract, so check, check. And the next thing that we need to do is create token issue flow. So as I mentioned at the beginning of this session, flows automate the process of updating the ledger. So the token issue flow includes the initiator flow on the issuer side, on the left side here, and as well as the responder flow, which is the owner side in the middle here. And we also have the notary on the right. And you might be thinking, why is there an initiator and a responder flow? That's just so complicated. Well, it's because flows take place between two nodes and they can be different. So for example, when a token is issued, each of these nodes will experience a different side to the process. So for instance, we see in the diagram, the issuer or the initiator in our case is doing all of the processes, which include choosing a notary, starting to build a transaction, add outputs token state to the transaction, adding the issue command, verifying the transaction, signing the transaction, and also sending it to the owner, also known as the responder. Whereas the owner, responder, they only have to receive the proposed transaction, review it, verify it, and then sign it and send it back to the issuer. So as a developer, we'll need to write the flows for both the issuer and the owner, or the initiator and the responder. But of course, in a production CorDapp, you might be writing only the initiator flow or only the responder flow, depending on which one is relevant. But of course, you might even have to write both initiator and responder flows for a variety of different transactions when the CorDapps become more and more complex. So in this example, we'll write one initiator flow and one responder flow for the token issuance. Okay, so let's go to our code and let's move into flow. So we can close this contract folder or minimize it more, and then go into a workflows folder and go into source, main, and that is where you'll find token issue flow. And we'll open up this file on the left-hand side, and then we'll have our test for these flows. So flow tests, we'll open it on the right-hand side. Move it to the right. There we go. All right, so let me just drag this along so we can see what's going on here. So let's go through the token issue flow file just to see what is happening. So online, let's go through here. Okay, so on line 41, we are here choosing a notary, as we see in this diagram here. Step 1, choose a notary. So we are already
Jenny, sorry to cut you off, but I want to say to the audience in the sessions today, so make sure you send your questions to everyone, not just the host and panelists, because I mean obviously I as a panelist, I can read your questions, but if you only send the question to host and panelists, the other people in the chat doesn't know what you are asking. So just make sure when you type in the question, send it to everyone instead of host and panelists. You should be able to click a button to choose that. Yeah, just that. Go on, Jenny.
Thank you, Peter. Yeah, if you have any issues with picking everyone, just let us know and we'll try and help you. But yeah, that's a good point to make. Okay. So going back to our token issue flow, so as we saw here for the issuer, the first step is to choose a notary. And we can see here in line 41, we're choosing a notary to use, so that is good. And then going back, we want to start to build a transaction. So here, in order to build a transaction, we need to define the token state for the input, right? And or for the output, apologies. So on line 46, token state, we want to put here, create a new token state. So new token state, and we want to put in issuer, owner, and amount, which are the 3 attributes that are required. And you might be thinking, where are we getting the issuer, owner, and amount from? So issuer, we're already getting our own identity. Owner is already defined up here, as well as the amount for the token issue flow initiator. So that's where we get our 3 attributes. And then on line 49 is where we want to build our transaction. So how do we do it? First, we do move this null, and we want to do a new transaction builder. See, as soon as I type new, it already suggests for me, right? So we want to put in the notary that we have defined on line 41 in here, so that we know which notary we want to use. And then we want to do add output state, and our preferred output state is the token states that we defined on line 46. So this is our desired output state. And then we need to let them know, so what do we want to do in order to get this output state, right? So we want to add a command. And our command actually takes 2 arguments. So the first is the type of command, and the second is the signing keys. So first we want to say the type of command, well, it is an issue command, so we want to do new token contract. It already suggests for us, so token contract.commands.issue, just press enter, and that's already done. And then the second argument is the signing keys. So we get the issuer's signing key and the owning key, sorry. So we get the issuer's owning key and the owner's owning key. So as list, oh, I need to, sorry, it's arrays, import arrays. And we want to get the issuer's owning key. See, it already suggests get owning key and owner dot get owning key. So that's all good. I'll finish it off with the semicolon. And then now that the transaction has been built, we'll actually need to, and we already add the issue command, we want to verify the transaction. So as you can see on line 56, we want to check that our transaction is valid based on the contract rules that we have set. So this is already done. And once that has been verified, the initiator or the issuer will need to sign the transaction, which is done on line 61. So they sign initial transaction, and this is how we get our signed transaction from the issuer side. But then, of course, this transaction requires the signature from both issuer and owner, right? So we need to initiate a flow with the owner so that we can communicate with them in order to get their signature. So we then initiate flow, initiate a session with the owner or the responder. And once a flow has been initiated, we'll use collect signature flows here in order to get the signature from the owner if they are happy with everything. So that is kind of what's happening with the initiator side of things. But then, as we said before, there's another side to it, right? There's the responder side of this flow. So let's scroll down, and there we go. That's where the responder flow is. Where are we declaring the owner from, asks Mike. Well, the owner is declared whenever we call token issue flow initiator. So we need to put in the owner as well as the amount for the token. So I hope that helps answer your question. So when the transaction is sent to the responder or the owner, this is when the responder flow will take place. So up here in the initiator flow, when we ask collect signature flow, that's when we call the responder flow. So this, as you can see on line 71, we annotate it by using initiated by token issue flow initiator class. So it is only initiated whenever we call it with the token issue flow initiator. And so let's take a look at what's happening in the responder flow. So as we can see here, this flow is initiated by a token issue flow initiator, as I just mentioned. And what's important to point out here is that in the responder flow, we actually do a check transaction class. So if I scroll down on line 87, we have check transaction method. And this takes a signed transaction, which is signed from the initiator side. So we take this transaction and we can put in any additional checks from the responder side. So it's optional. You don't have to do this because there's already the contract rules. So it's just if your own preference, like if you want to add more checks, you're welcome to do so. But in our case, we're already happy with the contract rules, so we don't need to add any more additional checks. And so this owner or the responder will then sign the transaction using the signed transaction flow. So here, signed transaction flow. So we have the signed transaction and we call receive finality flow, and we basically put the signed transaction in there. And so let's go back to our initiator flow because the responder is happy and has signed it and sent it back. So back to our initiator, we just want to scroll up. And once we have run the collect signatures flow, when the responder returns the transaction, we will get the fully signed transaction. So now it has both signatures, and we want to call the finality flow, which takes the fully signed transaction and get the transaction notarized and recorded on the platform. And this means that it will be on the ledger, it will be recorded on the ledger, and is therefore immutable. So I hope that kind of makes sense. And let's uncomment all of our tests for the token issue flow and give that a run to make sure that it's all passing. So let's go into flow tests and comment everything. And we want, to run flow tests. And as you can see here in our flow tests, we're setting up a mock network as well as creating these nodes to test with. And for that reason, it might take a bit longer because it requires a lot more work. So for your question, Mike, these lines are not synchronous because it needs to happen one step at a time, which is why we have our flow. So as you can see here, you can't have them all happen at the same time, right? It needs to choose a notary first, then build a transaction, et cetera, et cetera. So it can't happen all at the same time. Otherwise, it just wouldn't work. So in our case, we just run the flow and it automatically runs the steps for us. So, oh, yeah, Peter, do you want to say something?
Yeah, I can actually indeed add on to that a little bit. So it's actually by intention, every line is executed line by line because for all the Corda flow, we wanted to make it atomic, meaning each flow should finish, or we should say like we are looking for finality of the flow, because what we are doing is, let's say, high value transactions. we do not want a transaction to hang. We want it either finish with a success or it fails, and then we know exactly which line that it stopped. So if we have a lot of flows intertwine with one another, then we don't know which, like we will see a flow that is like hung up, but we will have invested a lot of time to figure out which subflow that is causing it. If we are allowing sort of randomly concurrent flow happen simultaneously. So that's like one recommendation we give to our customers is we always suggest that you write your flow in a atomic way, meaning every flow just do one thing, right? And then we looking to make that flow to have a final verdict whether it's gonna fail or pass. Yeah, I just wanna say that sort of is another angle from the design level why is executing one by one, and then we even have a diagram for that. Yeah.
Mm-hmm. And Arabinda asked, so will it not create a scale problem? Do you have any additional?
So I mean, can you elaborate a little bit on that? So I mean, a scale problem in which way? Because thinking about transactions, we care about finality. The Corda 4 the Corda 4 communication engine is also AMQP and Artemis. It's also by queue, like one finish and then the other will come in. If it doesn't finish, it wait until you get the answer. It just hangs, right? So it's always one by one. In terms of the scale, as atomic is the objective, we create other design problem. Well, I mean, it's at the end of the day, it's a trade-off. It's like whether you want sort of concurrency, multi-threadings, well, I mean, not multi-threading, like shardings, or maybe we do, Corda Enterprise do support multi-threading. So like how you allocate your CPU to handle one flow is fine. It's not like the problem we're talking about. It's just we do not want multiple flows to join together to compete with one another. can you please elaborate what happens when parallel flows are executing from the same and different counterparty? So they will execute one by one.
This wasn't shared with everybody, so maybe just repeat the question.
Yeah, I can repeat the question. So the question is, can you elaborate what happens when parallel flows are executing from same or different counterparties? They will, from on the outside, it looks like they are happen concurrently. The node is executing the flows all together, but inside of what happened in the core is one flow will execute, and if it's waiting for something, it will suspend, and then the other flow will execute, and then the other flow will get the signature from the counterparties. If the counterparty is not responding at that instant moment, that flow will suspend, and maybe the third flow will comes in. And then what happened is, okay, whoever's response comes back first, that flow will resume and then finish, and then the other flow will resume and finish, other flow and will resume, finish. So you see even on the screen right now, on line 38, there's a word called suspendable, meaning all the Corda flows is guaranteed to allow it to stop and wait and continue and resume. Question is, can we see and check suspended flow in the database or anywhere else? Yes, you can open a list of all executing flows in the terminal, Corda node terminals. I think it's called a flow watch. Any example on multi-threading and how we write in Corda? Multi-threading is not supported with Corda open source. Yeah, so it's one of the enterprise features.
Okay, cool.
Which means we will not be covering in our sessions. That would be a little bit sort of the upgraded versions of Corda community.
Yeah, thank you so much, Peter. Okay.
Yeah. Okay.
So now that we have built our token state, our token contract, and our token issue flow, and all the tests seem to go fine and are passing, so I think we're good to move on to our next step, which is number 4, to build, run, and interact with our nodes. So we want to build a test network of nodes. So I'm using a Mac, so I'm going to do Gradle W build deploy nodes. So I'm going to use my Gradle plugin here and to build. Just give that a moment. And as you can see, it is building the jar file. Let's give it a moment. I probably should have done that just now when you were answering questions, Peter, but oh well. I know we're 4 minutes over the time, but we're really close to the end. So if you can stay on, then definitely stay on. And as you can see, if we go into the build folder, that is where, Mike said, can a CorDapp interface with other UI apps made in React or Vue.js, I'm guessing? You can link it together, and you can use the CorDapp with a React app if you want to. And Arabinda, how does Corda manage its own network? Is it SDN? Do you know the answer to this, Peter?
So Corda, again, we're gonna talk about it with Corda open source and Corda enterprise. So with Corda open source, you can set up your local test deployment network with like what Jenny is doing right now, generating some local node directory by using the template. So that's one option. Option two is using the network bootstrapper. You can deploy to the virtual machine and then set up your remote network. But for open source, we do not offer any production network tool. For enterprise, we do have the Corda Enterprise Network Manager, and you can set up your private network, meaning you're gonna handle all the certificate, onboarding, offboarding of your own customers, customer KYC, stuff like that. So that's for enterprise option one. For enterprise option two is we have the global Corda network. You can just join the global Corda network. We have a lot of our customers are using public Corda network. So that's that. Next questions is in continue.
Suraj, can you make sure when you send a question that it's for everyone, just so everyone in the session can see, and not just to hosts and panelists?
Okay, I think when you say previous questions, okay, so so I'm trying to pick up where you mean previous questions. Do you suggest optimize the blocking flow in scenario where there's external flow validation dependencies? I'm not getting that. So maybe when you like elaborate a little bit, we can answer that. So the next question: what is impact of version 5 on this flow? I'm not again. I'm not quite getting what's V5. Well, I mean we have Corda 5, but I'm not sure if that's what you mean. So that's that. Next question: if we need to communicate two nodes over the public network, then do we need to bring in VPN first, considering I'm using the open? No, you don't need any VPNs. So the Corda network, I mean the communicating protocols is communicating just on the TLS. You can just send data over the public internet, no issues. Can we run Corda in the NGX servers? No, well, I don't think so. So the Corda environment is a GVM, and is actually quite. It needs, I would say, above average or above normal resource. It needs at least 2 GB of RAM and then 1 GB of swap, and some disk memories. So if it's not just like you deploy a website. So and it's for sure require Java GVMs. Yeah. So that means you're gonna find it very difficult to deploy Corda in a Raspberry Pi, because Raspberry Pi currently with the GVM is still like struggling, and plus with all the RAM allocations. Yeah.
Great. Thank you so much, Peter. What would I do without Peter? I don't know. Okay, so so as we can see here that we've run Gradle build and deploy nodes. So we can actually start the nodes, and I will actually start it in iTerm just so that we can see the nodes a bit easier here externally. So I hope the terminal is big enough for you. So I'm just going to CD into the folder where I have the CorDapp. And I just want to make sure I'm running the right Java version. So 1.8. Great, that's the one I want to use. And I'm going to do build nodes, run nodes, this command here, and press enter. And this should start, as you can see here, an external terminal. And I'm going to zoom in again. Oh, actually, I'm going to make this a bit smaller. And then zoom in. Okay, I hope that's big enough for you to see. And so, party A actually didn't start, so I'm just going to restart it, or you can just terminate it.
Jenny, you can keep it's okay.
Sorry,
Okay,
kill
it's-
the term, kill the
No,
node.
it's okay. No, just go, redeploy, go.
So run it again. And as you can see here, we have notary, we have party A, we have party B, and also party C. And I'm just gonna pull this out a bit so we can see it on one line. Okay, so we have A, B, and C. Oh gosh, I need to zoom in a bit more. Okay. Okay, I hope this is big enough for everyone to see. All right, so how we want to interact with the nodes, actually, as a first kind of line, you can see here, you can actually find out what is available if you type help in each of these nodes. So if I just type help, you can see here, there's like attachments, buy, checkpoints, exit, flow, hash lookup, help, etc. Right? And there are loads of different commands that we can use. What we want to use here is, let's say, I want party A to be the issuer and party B to be the owner. So I want to issue a token. I want party A to issue the token. So let's say we can run commands to work with flows, right? And we want to run the issue command here. So flow start, or sorry, we want to run the token issue flow. So flow start, token issue flow initiator. And we want to set the owner as party B. And let's say I want to set an amount of 19. So I'll press enter. Oh, I think I need a space. Great. So it takes a couple of seconds. It should be pretty fast. And it's already finished running this token issue flow. So as you can see here, it starts, and then it requests signature by notary service, and then validating response and broadcast transaction to participants involved. So the participants involved is party A and party B. And the flow completed with result. And we have a unique ID here. And so now we've issued the token. And if you want to have a look and see what it looks like, then we can do run vault query. And this is where the token state is stored. So we want to query the vault and check for any contract state type, which is equivalent to token state, which is what we created, right? So let's do contract state type is com.bootcamp.states.token state, which is where we created our token state. So press enter. And as you can see here, let's scroll a bit. So the issuer is party A. Owner is party B. Amount is 99. That's correct. And the contract is token contract. That's correct. Notary is a notary that we set. And it also has a transaction hash that you can use to kind of look it up as well if you want to. And so that's great because as an issuer, we should be able to see the token state, right? So what about the owner? As an owner, do you think we should be able to see the token state? The answer is yes, right? Obviously, we want to be able to see it. So we can run the exact same command in party B, com.bootcamp.states.token state. Let's hope I have no typos here. And same thing. it gives out the exact same results here. Issuer party A, owner party B, amount 99. Contract is token contract, same notary, and it should be the same transaction hash. And I want to ask you, do you think party C should be able to see this state or transaction? Do you feel like no? Yeah, exactly. You already know what I'm gonna say. So if we query this vault, we should actually not be able to see the transaction. And as you can see here, it is empty. And this is because Corda communicates on a peer-to-peer need-to-know basis. And we defined in Get Participants that is only issuer and owner who should be able to see the token state. So in that case, as party C is not part of the transaction, they are not able to see the state in the transaction. So that's basically it for today. I hope that everything was quite clear for you to understand and that you were able to follow along. And actually, if you like to go through this bootcamp in your own time and you want to check the solutions at the very end, you can find them in solutions.md in the same GitHub repository. So I'll just show you. So this is a GitHub repository that we cloned from. And as you can see, contracts and workflows are the two folders that we worked in. And in order to get the solutions at the very end, solutions MD is where you'll be able to find it. So there you go. That's everything for today. And before we finish up, I actually want to ask you a final 2 questions just to see if you really understood what we talked through. So the very first question is, where does each node store their states? Is it A, ledger, B, blockchain, C, vault, or D, notary? And if you're not sure about this, you can have a think back to what we typed in the terminal. What did we query in order to see the states? Yeah, most people answered C, which is correct. So the states are stored in the vault, and we use run vault query so that we can see what state is in each party's vault. Okay, so the next and final question, transaction builder should be used in which Corda class? Is it A, state, B, contract, C, transaction, or D, flow? Where did we have new transaction builder? Do you remember? Some people saying C, some people saying D. Most people saying D. And yes, the answer is D. It is the token issue flow. Do you remember? So as we saw previously, we only use the transaction builder when we're writing the token issue flow. So that is where it should be used. And that's basically it, I guess, for today. And if you're thinking, okay, so now that I've done this workshop, what are my next steps? So here are a couple of next steps that we can recommend to you. You can perhaps take the Corda developer certification, because all of the questions that you answered today in the midpoint check-in and as well as at the very end, there are questions that will be asked in the Corda developer certification. And for a limited amount of time, if you sign up to the R3 developer platform, you'll actually get to do the Corda developer certification for free, and it's usually 150 USD. So make sure that you do that so you don't miss out on the offer. I'll put the link in the chat. And the second step is to make sure that you come along to CordaCon 2022. This will take place on the 27th and 28th of September in London, which is in just under 2 weeks now. Most of the developer relations team will be there. I hope Peter will be there too. I'm not sure yet. But yeah, you'll be able to meet the team, ask any questions that you have, as well as see a lot of real life use cases and also businesses that we work with. So 27th will be the business day and 28th will be the developer day. So make sure you sign up and come along, because it's going to be a great learning experience and also great for networking purposes. And final thing before you go, I want you to, I would hope you would take 2 minutes to give us a bit of feedback from today's session. So I'll put a link in the chat just to let us know, what have we done well, what can we improve on, as we're always trying to do better and to provide content as much as possible for you all. Martin said, can a party that receives token in the future see the history of state? Yeah, yes. Peter already answered the question. Okay, great. Cool. So take 2 minutes to leave your feedback. And that's basically it. Thank you everyone for coming along today. I know that was a lot. So, you know, if you need extra time to absorb everything, then feel free to check the GitHub, as I mentioned before. But also, if you have any questions still after the session, then definitely get in touch with us. We have LinkedIn, Twitter, Slack, and we also have the training website for Corda. So I'll put it in the chat as well so you can access it easily. And if you're stuck, don't forget that, you know, we are a community of developers to help each other. So don't learn on your own. Be sure to come along and ask us questions, start conversations. And yeah, thank you so much, everybody. I hope you enjoyed today's session, and we'll see you very, very soon. Hope to see you at CordaCon in 2 weeks. Bye, everyone. Thank you. Oh, Mike, to answer your question, the free link for the certification, you just have to sign up to our developer platform. So I put the link here, Corda developer platform. You just have to sign up, and then you'll be able to do the certification for free. Okay, thanks everybody. Have a good day. Bye.